everyone, I hope you are doing well. Welcome to Waves and Optics class. And this is lesson 1, Oscillation and Basic Wave Concepts. So this is on understanding how energy moves through matter. Before I proceed, let us know what are the learning objectives for this lesson. So today, we will classify waves as transverse or longitudinal with at least 90% accuracy, calculate wave frequency and period from experimental data correctly in 4 out of 5 trials. Third is perform an experiment using a slinky and gather data to determine the period and frequency of transverse and longitudinal waves. And lastly, demonstrate oscillatory motion using a pendulum following a proper procedure. So before we proceed, let's take a moment to check in with yourself. So think about how are you feeling today? Are you feeling happy? Excited? Because we are going to learn something interesting today? Or you're feeling sad and tired? I know na marami tayong need ipasa during this month, and I understand na lalo nadadagdagan ng ating stress at kaya tayo walang energy, but that is okay. So I want to ask you again, how are you feeling today? Okay? So, whatever you are feeling is totally okay. So, sabi ni Dr. Tal Ben-Sahar, so, isa siyang professor in psychology in Harvard, sabi niya na, give yourself the permission to be human. So, this simply means you don't have to be perfect student or a robot today. So sometimes we think we should feel a certain way. For example, you should feel happy and excited kasi manonood ka ng video lesson na to, but it's totally fine with me if you don't have the energy or not interested to learn. You just want to watch this video to answer the questions para mabawasan na yung mga other task mo, but that is okay. But I hope you try to listen and understand the lesson para sa mga sumunod na mga lessons related to this ay hindi ka na mapag-iiwanan. But being human means our moods change, and that is perfectly natural. When we stop fighting how we feel and just accept it, we actually open up more space to learn and grow together. So, whatever you're feeling right now, it's totally fine, and I hope you're okay. So, today as we explore a concept that we experience almost every day without even noticing it, we are going to talk about waves. So, but before we understand waves, we first need to look at a special type of motion that helps create them. So let us begin with a short activity. So before you answer the Padlet link that I will provide, please listen to the instructions first. So your task is to draw an object that shows back and forth motion. After drawing the object, write one sentence explaining how it moves. So think about objects that repeat their motion again and again. For example, you might draw a swing moving in a playground, a pendulum in a clock, or a guitar string that vibrates when it's plucked. As you think about your example, pay attention to how the object moves. Notice that these objects do not travel far away in one direction. Instead, they move back and forth around the same position. So, once you have finished your drawing and explanation, you may continue watching the video. So, thank you for answering our Padlet activity. Now, let's try a quick challenge. So, please open the word wall activity using the link provided later on. So, in this activity, you will observe different types of motion. Your task is to determine which motion shows repeating back and forth movement. So, think carefully how the object moves before selecting your answer. So, once you finish the activity, return to this video so we can continue our discussion. So, after you answer the word wall activity, please don't forget to put your names in the leaderboard since imo-monitor ko if nagsagot ba kayo or hindi. Para makita ko kung sino rin yung mga nagsagot. So, thank you. Please answer the word wall activity now. Now that you have seen several examples of objects that move back and forth, let us talk about what this type of motion is called. So in physics, this motion is known as oscillatory motion. Oscillatory motion is a motion that repeats back and forth around a fixed point or a central position. So instead of moving continuously in one direction, the object moves to one side, returns to the center. So, ganito siya. So, one side, returns to the center, then moves to the other side, and repeats the same motion again and again. Ganyan. So, oscillatory motion tawag dyan. So, let us think of a simple example. Yan. So, imagine a swing in a playground. So, itong example na to. So, when someone pushes the girl forward, it moves, nagmo-move forward, then it slows down, stops for a moment, and moves back in the opposite direction. So, after that, it continues repeating the same pattern of motion. Diba, kapag tinutulak tayo ng mabilis, ang hirap ng pigilin yon na tayo lang mag-isa, need na natin ng katulong. Naranasan ko yun eh, takot ako nun. But anyway, even though the swing is moving, it does not travel far away from its original position. Instead, it keeps returning to the same central point. So, observe the girl here. As you can see, habang nagsiswing siya, kung ito yung central point, nadadaanan niya pa rin to, bumabalik pa rin siya doon. Right? So, this repeating motion around a fixed position is what we call oscillation. Another example is this pendulum swinging. So, as you can see, na kapag ginalaw natin itong isang bola, gagalaw din po yung kabila. Kasi ito po yung central point ng pendulum. Kapag naman ginalaw mo po itong dalawa, ang gagalaw naman po ay itong isa lang. Ito naman yung magiging central point niya. Pero kapag ginalaw mo ay tatlo, ang central point niya ay yung dito mismo, dito sa gitna. Kasi pag ginalaw mo yung tatlo na yan, dahil gagalaw yung tatlo, gagalaw din yung isa pa nagtama sila, di ba? So now you might wonder why this motion or why oscillatory motion is important when we study waves. So the reason is that waves are produced when many particles in a medium oscillate repeatedly. When one particle begins to vibrate, it transfers energy to nearby particles, causing them to vibrate as well. So this chain of vibrations allows the wave to travel through the medium. So, kapag paulit-ulit na po yung pag-o-oscillate ng isang bagay, ang tawag na po doon kapag paulit-ulit na po yung pag-oscillate ng isang bagay, magiging wave na po siya. So, in simple terms, oscillatory motion is the foundation of how waves are created. So, before we proceed, I have a question. In your own words, what is oscillatory motion for you? So, thank you for answering. Now, that we understand how objects move back and forth repeatedly, the next step is to see how these motions travel through a material. So, kasi nakalagay dito sa PPT natin na waves are created when many points in a medium oscillate repeatedly. So, this brings us to an important concept called what is a medium? So, before we continue discussing waves, we also need to understand an important concept called a medium. So, a medium is the material or substance through which a wave travels. So, in other words, it's the matter that allows the wave to move from one place to another. So, for example, etong water waves. Water waves travel through water. As you can see naman. Sa example, diba? So, sound waves travel through air. If you shake a rope, the wave travels through the rope itself. So, in each of these cases, the material where the particles vibrate is called the medium. The particles in the medium do not move long distances. Instead, they vibrate or oscillate around their original position, transferring energy to nearby particles. However, it is important to know that not all the waves require a medium. Some waves, such as light waves, are able to travel through empty space. So, light waves is an example of electromagnetic wave. But, that topic will be discussed by other teachers po. So, but for many types of waves that we observe in everyday life, such as sound and water waves, a medium is necessarily for the wave to travel. So, I have another question. Now that you know what is the meaning of medium, can you give me 2 examples of materials that can act as a medium for waves? Okay, thank you. Thank you for giving me examples. So, to better visualize how energy moves through a medium without the particles traveling far, let us look at a fun and familiar example, the Mexican wave at a stadium. So, I believe familiar po kayo sa Mexican wave. So, ito po yung usually na ginagawa sa mga sports game, or sa concerts. Kung may nakapunta na sa inyo sa concerts, usually ginagawa itong wave na ito. They usually call it a Mexican wave. So, from far away, this creates what we call a stadium wave or sometimes a Mexican wave kasi at some point, one group of people stands up and raises their arms. Then they sit down. After that, the people next to them stand up and do the same movement. Now, think carefully about what is happening. Are the people running around the stadium? Napansin nyo, alam ko, nakapanood na kayo ng mga Mexican wave dato, and Ako din, nakapanood na rin ako, and nakakatuwa siyang tingnan kasi nagwe-wave yung mga tao. Pero napansin nyo ba na nagpupunta sila from one place to another, tumatakbo ba sila ganon? Syempre, hindi. Kasi each person simply stands up and sits down in their own places. So, gaganon lang sila. Woo! Gaganon lang sila sa pwesto nila. However, the motion appears to travel through crowd. So, this situation is very similar to what happens in a physical wave. So, in waves, the particles of the medium do not travel far from their original position. Instead, they move back and forth or up and down in their own place. However, the energy of the motion travels through the medium, just like the motion travels to the crowd in the stadium wave. So, this idea leads us to the definition of a wave. So, waves are disturbances that carry energy from one place to another. An important idea to remember is that waves transfer energy, not matter. So, ibig sabihin po nun, ang nagtatransfer lang po sa waves ay yung energy. Hindi po kasama dito yung matter. What do you mean ba by matter? Ito po yung anything that occupies space. Ito po yung solid, liquid, or gas. So, energy lang po yung tinatransfer niya ha, hindi matter. So, ito nga po, sabi natin, most waves require a medium. Electromagnetic waves can travel in a vacuum. So, for now, we are just going to focus on this. And this one will be discussed by other teachers. That we have discussed what is oscillation motion and what is a wave. Now, let's move on to classifications of waves. So, sa waves, merong dalawang type ng wave. Ang una po nating i-discuss ay what is a longitudinal wave. So, in longitudinal waves, the vibration of the particles occurs parallel to the direction that the wave travels. So, if we look at this diagram, you will see two arrows. So, one arrow shows the direction of the wave or the wave propagation, which tells us the direction that the wave is moving. So, kung ito po yung wave, dito po sa right side ko, papunta yung wave. Kung saan ko po ito tinuturo, dito po yung direction ng wave. And the other arrow shows the direction of direction of vibration, which tells us how the particles of the medium are moving. So, kung paano nagmo-move yung wave na ito. Itong yellow arrow, pinapakita niya kung paano nagmo-move ang wave. Ang direction of wave propagation is saan papunta yung wave. So, tatandaan po natin ha. Direction of vibration, paano? Direction of wave propagation, saan? Pero, kung titingnan natin, parehas din naman din sila ng tinutumbok. So, this means that the particles move forward and backward in the same direction that the wave travels. Because of this motion, two important regions form in the medium. So, the first region is called compression. In this region, the particles are pushed close together. So, as you can see, pag ginalaw itong kamay, magko-compress yan sila together kasi from the word compress. So, magko-compress sila. And the second region is called rarefaction. In this region, the particles are spread farther apart. So, habang gumagalaw po yung itong wave na ito, maghihiwa-hiwalay po yan sila. Ayan o, magsispread sila farther apart. So, as the wave travels through the medium, these compressions and rarefactions move from one place to another. So, a classic example of a longitudinal wave is the sound we hear every day. So, let us see how vibrations in the air particles create the sound around us. So, sound is produced when an object vibrates. So, when the object vibrates, it causes the surrounding air particles to vibrate as well. So, these vibrating air particles create a pattern of compressions and rarefactions. So, as you can see here, this is the compression. Nagko-compress po sila, di ba? Ayan. And then, the definition of rarefaction is to spread apart po yung particles. So, as the compressions and rarefactions travel through the air and reach our ears, our brain interprets these vibrations as sound. So, this is how we able to hear music, voices, and other sounds around us. So, baka po malito kayo ha, na ito pong radio na to, we are just making an example of this, yung sound na nilalabas niya. Hindi kung paano po natin nare-receive yung sound na nanggagaling sa radio. Okay po ba? Ang ina-example po natin dito is paano po natin naririnig yung sound na nanggagaling sa radio wave. Hindi po yung paano natin nare-receive yung sound na nanggagaling sa radio sa pamamagitan ng antenna. Okay po? Kasi magkaiba po yon yung radio waves. Okay? So now, not all waves move in the same way as sound. So, we will look at transverse waves where the motion of particles is at right angles to the direction of a wave.
In a
Pero, tingnan pala muna natin if paano ba yung galaw ng isang longitudinal wave. So, yung papakita ko pong example sa inyo ay demonstration lamang po ng paggalaw ng longitudinal wave. So, hindi po example ang slinky kapag sinabi nating longitudinal wave. Okay po ba?
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves. In a longitudinal wave,
as you
the
can
disturbance
see,
that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves.
As you can see, nakita po natin yung compression. Yung compression po niya.
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves.
Nakita po natin yung compression niya and yung rarefaction. Okay po? Ngayon, mag-move on na po tayo sa transverse wave. So, in transverse waves, the vibration of the particles occurs perpendicular or at right angles to the direction the wave travels. For example, imagine shaking a rope up and down. So, when you move your hand up and down, so pag ginanon yung rope, ginanon nyo. So, when you move your hand up and down, the particles of the rope move vertically. However, the wave itself travels horizontally along the rope. So, this means that The motion of the particles and the motion of the wave are in different directions. Because of this type of motion, transverse waves form patterns with high points and low points. So these high points are called crests, and these low points are called throws. Throws. I think kayo na po search ano bang tamang pronunciation, pero basa ko po ay throws. So ito po siya. Crest and then throws. But we will dig in deeper on that later. So, to make this idea more concrete, let us examine what happens when a guitar string is plucked. Okay, now that we have finished watching the video, I have a question for you. So, bakit naging perfect example ang guitar ng transverse wave? So, again, ulitin ko lang po. Why is the guitar an example of transverse wave? So, please answer the question below. So, thank you for answering the question. So, when a guitar string is plucked, it begins to vibrate rapidly. So, the string moves up and down from its original position while the vibration travels along the string. So, because the particles of the string move up and down while the wave travels along the string, this motion is a perfect example of transverse wave. So, nagagets po ba? Kung nagagets po natin, let's try to check your learning. So, classify the following as transverse or longitudinal waves. So, your number 1 is sound waves, light waves, waves in a rope, a slinky pushed forward and backward, and number 5, ocean surface waves. So, please analyze it carefully and then answer the question below. So, thank you for answering the questions. Ngayon, tingnan natin if yung mga sagot nyo po ba ay tama. So, ayan. So, yung sound waves, number 1, ang answer po ay longitudinal. Kung hindi nyo po natandaan, isa po ito sa mga examples na pinakita ko po kanina. Number 2 is light waves are transverse. So, yung light waves po ay example po siya ng electromagnetic wave. And, lahat po ng electromagnetic wave ay transverse waves. Kaya, ang sagot po sa number 2 ay transverse. Number 3, waves in a rope. Isa po siyang transverse wave. Ito po yung example natin kanina sa transverse. Number 4, slinky pushed forward and backward. Ito po yung demonstration na pinakita natin kanina. And ang sagot po dito ay longitudinal. Last is, ocean surface waves. So, ito po ay transverse wave. So, thank you so much po for answering, and I hope You got everything correct. So now that we can see how waves move along a string, it is important to note that the different parts of a wave and their characteristics. So now, let's move on po sa parts of a wave. So, ayan. Let's start with the crest. So, the crest is the highest point of a wave. So, ito po yung pinopoint ko po kanina doon sa transverse. So, think of it as the peak of the hill. So, ito po yung peak ng bundok. So, kung ito po yung peak ng bundok, ito po yung peak ng isang wave. Yung throw naman po is the lowest point of the wave or the undisturbed position. Ito po yung lowest point ng isang wave. Ang tawag po dyan ay throw, toro, basta yun. And between these 2 points is the rest position, also called the equilibrium position. Ito po siya. So this represents the normal position of the particles when they are not vibrating. It's like the flat ground before the wave passes. So, alam naman po natin na magsa-start pa lang ang wave kapag gumagalaw siya, right? So, ito pong part na to, yung hindi pa gumagalaw. Saka pa lang po yan gagalaw kapag nag-move forward na yung wave. Ganon po siya, okay? Tapos ito po, yung kaninang sabi ko, direction of wave propagation or kung saan po nag-move yung wave. So, in this example, na-move po yung wave through the right. Okay po? Another key property is amplitude. So, amplitude is the maximum distance a particle moves away from its rest position. So, in simple words, it is the height of the wave. So, yung kanina, if the crest is the highest peak of the wave, ang amplitude naman po is the height of the wave. Okay po? Pinagkaiba po ng crest, yung taas ng peak. Ito po, taas ng peak nitong wave. And yung amplitude naman, yung height ng wave. Okay po? So, here is something to remember. A wave with a bigger amplitude carries more energy than a wave with a smaller amplitude. So, think of big ocean waves crashing on the shore versus small ripples in a pond. So, isipin nyo po yung mga nagsisurf. So, kapag po mataas yung wave, mas malakas po yung bagsak nito, right? And magsisplash po siya sa atin. Kesa yung mga ripples lang sa water. Mahina lang yung wave nun. So, sana po na-imagine ninyo, ha? Yun po yung tatandaan ninyo kapag sinabi nating amplitude. So, here is an important point for longitudinal waves. So, ito po kasing mga examples na ito pong parts na kasi na ito, makikita po natin siya sa sa transverse. Pero since yung longitudinal waves ay ganito, the amplitude is shown by how close the particles are in the area of compression. So, the closer the particles are, the greater the amplitude. Meaning, more energy is carried in the part of the wave. Okay po? Kasi po, pag transverse po, di ba, ang kine-carry lang po niya is yung energy. Samantalang longitudinal waves, kasama po yung particles. So, as you can see po, may compression po dito. And then, ito po yung rarefaction niya. And then, kung gaano raw po magka-compress yung mga particles, yun po yung amplitude niya. Paano naman po kapag wavelength? So, the distance between two consecutive points between two compressions or two refractions. So, kapag sasabihin po nating wavelength ng longitudinal waves, ito po yung isang wavelength niya. Okay po. Isang wavelength po yan. Kasi sabi po, in between two points of compressions or two refractions. Okay po? So, second to the last is another key property is wavelength. Ito naman po yung sa transverse, which is the distance between two identical points in a wave cycle. For longitudinal waves, yun nga po, this is measured between two consecutive compressions or two consecutive rarefactions. Okay? Sa wavelength ng transverse, ganito siya. So, isang wavelength na yung ganito. Okay po? So, before we proceed sa frequency, quick question lang. What happens to air particles when sound waves travel through the air? So, please answer. Okay? Thank you for answering. So, sana po na-gets nyo po. Okay? Again, balik po tayo. Crest is the highest peak of the wave and throw is the lowest peak of the wave. And ito po yung equilibrium position kung saan ito po yung undisturbed position ng wave. Ito naman po yung amplitude, yung height ng wave, yung taas ng wave. And pag sa longitudinal waves, the amplitude is the closer the particles of the area of compression, the greater the amplitude. Kapag mas nagko-compress po yung particles, yun po yung amplitude. Kapag yung wavelength, two consecutive points po between two compressions or two rarefactions. Yun yung wavelength. And then, dito naman, wavelength is a distance between two identical points in a wave cycle. So, yung isang ganito po, isang wavelength na yan. Kapag ito, nag-continue pa, ang tawag naman dyan ay pangalawang wavelength na. Okay? So, ngayon, naman, once we know the size and shape of a wave, we can also ask how often these waves pass a point. So, this property is called frequency and it is very important in both sound and light waves. So, if many waves passes a point quickly, we say the wave has a high frequency. Ito po, pag mabilis yung niya, parang magkakadikit ang wave. Ang tawag po dyan ay high frequency wave. Okay po? Pag tinatanong, low frequency ba to or high frequency? Sagot dyan ay high frequency. If the fewer waves pass, it has a low frequency. So, sabi nga dito, it is the number of waves passing a specific point per second. So, bakit ba to important? So, frequency helps us understand the pitch of a sound. So, high pitch versus low pitch. And types of light like red versus violet light. So, yung mga sinasabi ko po dito ay madidiscuss pa sa mga ibang lessons. So, last question before we check your learning again. So, if a sound wave has high frequency, is it a low pitch sound or low pitch sound? And why? So, thank you. Thank you for answering the question. And I hope na-gets nyo po yung parts of the wave from crest until this part, which is the frequency. Okay po. So, learning check. So, tingnan po natin sa screen if ano po ba yung parts ng mga wave. And for number 4, how many wavelengths are there? And is the frequency high or low? Yan. So, paki-answer po yung question na magpa-pop up po sa inyong mga screen. So, thank you for answering. Let's check if tama po ba yung pagkaka-identify ninyo sa parts ng wave. So, okay. Number 1. Number 1 is the crest. Number 2 is the throw. Number 3 is the amplitude. Number 4, it has 2 wavelengths sa wave na to. Number 5 is, this is an example of low frequency. Okay? And last but not the least, number 6 is rest or equilibrium position. So, sana po, tama po yung mga sagot ninyo. Now, let's move on to learning check number 2. So, compare these two waves in terms of frequency, wavelength, and amplitude. So, again, pag sinabi po nating frequency, if how many waves pass a specific point in 1 second, yung wavelength, kung ilan po yung umuulit na wave, or yung complete cycle ng isang wave. So, yung isang ganto, isang cycle na po yan ng wave. Amplitude, yung height ng wave. So, tingnan po natin yung mga sagot po ninyo. Yan. So, sa amplitude A, same siya sa amplitude A. Sa wave A, same sila ng amplitude sa B. Pero, mas longer yung wavelength niya and mababa yung frequency. Unlike sa wave B, na same pa rin ng amplitude as A. Pero, mas shorter yung wavelength niya and mas high ang kanyang frequency. So, sana po na-gets nyo po itong lesson na to, itong oscillation and basic wave concepts. And yung calculate part po sa ating learning objectives ay i-discuss po ni Miss Abarhedo. So, ayun po. Thank you very much for listening, answering the questions, and pag-intindi po sa lesson na to. So, if you have questions, don't hesitate to message me or mention me sa ating GC. And if you have clarifications, don't hesitate again sa pagtatanong, okay? So, yun lamang po. I see you again sa ating susunod na lesson. And thank you. Bye-bye!